Alright, we're going to talk about the electron configurations. So electron configuration is just a way of representing all the electrons an element has going from lowest energy to highest energy. The easiest way to do this is to just follow the periodic table. So you go from left to right and you follow electron configuration accordingly. So for example, I'm going to go 1s2, 2s2, 2p6, 3s2, 3p6. So I'm just going to follow the periodic table going from left to right until I get to the element I'm looking for. The point of all this is to show you that the periodic table can be broken down to different parts. This is called the S block. So all elements that are here end at S1, all the ones here end at S2, then you go D1, D2, all the way to here, which is D10. Here we have P1, P2, P3, P4, P5, and P6. One thing you want to note about this, actually two things, is one, S and P just follow the shell number. So you can see this is period 1, 2, 3, 4, 5, 6, 7. Whereas the D block is 1 minus your shell number. So you can see the D doesn't begin at 4D, it actually begins at 3D, even though it's in the 4th period. F is also weird. These two F's blocks elements are actually members of period 6 and 7. And the way you figure out which F you're starting with, it's n minus 2. So it starts after 6s, so it's 6s, then it's 4f, then it's 7s, and then 5f. I should point out it should go 6s, 4f, 14, then the D's come into play, 5d, 10, and 6p. So let's look at some examples to see if we can make more sense of it. So here's a periodic table. And you can see from this, once again, this is all S1s, these are all S2s. This is P1, P2, P3, P4, P5, and P6. So that's going from left to right. We're going to look at an element. So I'm going to start with fluorine. So if you can see, fluorine is right here in the periodic table. All right, so my stop sign for this is going to be basically P5. And since it's in the second period, 2p5. So I'm going to show all the electrons and I'll stop at 2p5. So for fluorine, we're going to start at 1s2, 2s2. All I'm doing is following the periodic table. I'm going from 1s1, then I'm going to 1s2, then I'm going to 2s1, 2s2, and now I'm into 2p's. And you can see that you go P1, P2, P3, P4, P5. So my stop sign for this is P5. So I will put the 2p5. Now I can verify that I did it correctly by counting my total number of electrons. Fluorine has atomic number 9. You can see down here, you actually have 5 plus 2 plus 2. That's 9 electrons, so I'm good to go. Let's try another one. Let's try nickel. Nickel, same concept. I'm going to look to see where it is in the periodic table. So you can see nickel is right here. So my stop sign is going to be 3D8. Now my stop sign is basically all I'm doing is seeing where the element is located, and then identifying is it P, D, or S, and then I'm going to say, okay, well here it's the 4th period. So remember, 4th period is going to have 3D after 4S. So in this situation, because it's the 8th electron, you can see 1, 2, 3, 4, 5, 6, 7, 8. I'm going to stop at 3D8. So just like with nickel, I'm going to start at 1s2. So you follow the exact same sequence every time. 2s2, 2p6. Now you have to fill that subshell before we go to the next one. If you've forgotten, S can hold a maximum of 2 electrons, P can hold a maximum of 6, D can hold a maximum of 10, and F can hold a maximum of 14 electrons. So in order for me to finish that letter, I have to max out the number of electrons that could exist there. So that's why I'm going S2 and P6, because I have to fill this subshell before I go to the next one. So then I have 3S2, 3P6, 4S2, and now the D block begins. I remember D is one less than the period number. It's in the fourth shell, so it's going to be 3D. And remember, our stop sign is at 3D8. Once again, you can see the total number of electrons matches, which is 28. You can just count the exponents if you don't believe me. 2, 4, 10, 12, 18, 28. We know we did it correctly. All right, let's look at the two more. Iodine, which is a much longer molecule. It's all the way over here. Number 53. So I need to go all the way to 53. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. And remember here, let's just go back real quick and just point out the fact this is a member of the fifth period, and it looks like 5, so I need to stop at 5p5. That's when I know I did it correctly. So let's get back over here. So 4d10. Remember, after 4d10 comes 5p, and our stop sign is a 5. All I did was just follow the periodic table left to right until I got to my destination. And if you count the total number of electrons, you get 53, so you know you did it correctly. All right, let's do one F block just for practice. So we're looking at this one, EU, atomic number 63. So once again, 1s2, same pattern. It does not change. The only thing that changes the stop sign, I should have pointed at the stop sign. So this is looks like 4F. Remember, this are 4F, and this is 5F, because remember, it's a period 6 and period 7. 2 less than the period number is what the F is going to be. So if you look at it, this is F1, F2, F3, 4, F5, F6, F7. So 4F7. That's when I got to my destination. So let's keep on going. 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, and remember, after 6S, we actually 6S2, we actually get 4F. So 4F, and go all the way to your destination, which is 4F7. And that's because, remember, over here, this group over here is actually a member of over there. So that's why we do it in that sequence. Hypothetically, if we had to go to like lutetium over here, then we do 4F14, and we would end at 6D2. So that's how you do electron configurations.